What's going on, everyone? Welcome back to the channel. In today's video, we'll be talking about the BME280 pressure, temperature, and humidity sensor, and we'll essentially be talking about how does this thing work on a MEMS level. So we'll be going over some high-level MEMS concepts of how we actually retrieve pressure, temperature, and humidity values from the sensor. So for those of you guys who are curious about how this thing actually operates, this is the video for you. We're not going to get into the weeds too much. We're just going to talk about simple MEMS concepts and essentially how we can deduce pressure, temperature, and humidity values from MEMS structures. And I think it's pretty interesting for those people who have been working with this sensor for a long time. It is a pretty popular sensor for environmental sensing purposes in Arduino and Raspberry Pi projects. So enough being said, let's get into it. The first thing we're going to talk about is pressure and how we get pressure from this sensor. Okay, so pressure. How do we get pressure from the BME280? How does this mini thing give us some form of pressure indication? Well, fortunately, Bosch actually shared this online. They don't share too much information about this sensor due to intellectual property purposes, but they actually showed a quick YouTube video about 50 seconds of how this thing manages to measure pressure. And the working principle of how the BME280 manages to measure pressure is mainly on the concept of a piezo-resistive Wheatstone bridge. Now that can seem intimidating for people who have never worked with circuits. Me, with a computer science background, that was certainly intimidating. But if you read about it online, a Wheatstone bridge is actually a very common and simple circuit mechanism that is known to be incredibly accurate to measure unknown resistances. So it's a very accurate circuit structure where we can deduce information of our system. And that's why it's used in this BME280 to measure pressure. And what's happening is this piezo-resistive Wheatstone bridge is actually sitting on top of a pressure-sensitive membrane, which is surrounded by the resistors of this Wheatstone bridge. And when a distortion in the membrane due to a change in pressure of the system happens, let's say we go at a higher altitude or a lower altitude, this will change the concavity of the membrane, which is proportional to an electrical voltage which is created at the resistors and can be measured at the terminals of the Wheatstone bridge. Now I know that sounds scary, but it's actually pretty simple, and you can read more about Wheatstone bridges online. And in this next slide here, we see the illustration directly from Bosch, and this is from their YouTube video. You can just go to this link here and watch it. It's 50 seconds. It doesn't show much more information than what I'm explaining in this video. And so we have the piezo-resistive bridge on the left there sitting on top of the green membrane, and we have the terminals in the corners there which we can measure that voltage. And once pressure happens, in this case we could see a change in concavity, which can be measured essentially at the terminals of the piezo-resistive bridge. And knowing the properties of the system, we can essentially deduce how much pressure we are experiencing on the system. And mind you, these things are very consistent, so they probably know exactly the properties of this piezo-resistive bridge and of course the resistors. And knowing all that information, I do not have the mathematical equation because that's probably intellectual property from Bosch, but we can deduce the pressure experienced on the system. So that's how pressure is working at a high level on the BME280. So next, let's talk about humidity. Okay, so how do we get humidity from the BME280? Well, unfortunately, Bosch, the company that makes the BME280, does not disclose the exact mechanism. However, we can deduce from other popular MEMS structures how we can get humidity from such a sensor. And that probably works on the concept of capacitive humidity technology. And like I said, the exact details are not shared by Bosch for IP intellectual reasons. So first of all, what is capacitance? That is the ratio of change in an electrical charge in a system to the corresponding change in electric potential. Now, this is usually a stagnant property of a system. However, in this case, what happens is we have this porous layer, this porous capacitive layer between two electrodes. And by porous, what can happen is when the humidity around the BME280 changes, that water can get lodged in this material. And when water gets lodged in this capacitive material, it will essentially change the capacitance of this material, which can be measured by the top and bottom electrodes. So that's speculated of how the BME280 manages to measure humidity. We do not know the exact material this is made out of, or 100%, we are not certain how they do it. Maybe they use some other technology we haven't heard of, but based on my research online, this is a really popular mechanism to essentially get humidity from a system. And this can measure humidity from 0 to 100% humidity based on using structures like this. So as I said, the main mechanism consists of sensing material sandwiched between two electrical diodes, which can measure a change in capacitance. So in the next slide here, we have more information of how a structure like this would work. And as I mentioned, we have the sources down below, so you can look at that online. But the sensitivity of this structure can be attributed to the layer thickness, the pore size, the area, etc. And we have sort of a cross-sectional view of what's going on. We have the top and bottom electrodes, and we have sensing material in between. And we have some air pockets where water molecules can lodge themselves in there. And as I mentioned, capacitance changes as water molecules lodge themselves in the material. And another thing we have, as you saw on the previous slide, in such mechanisms is we can add a heater on the bottom there to make sure we have faster response times to allow water to evaporate more quickly. So it is common to have a heater in such systems to increase the response time of such a system. So unfortunately, we don't have the exact mechanism of how it works at Bosch, but we can do a pretty strong speculation of sort of how they would measure humidity pretty accurately, 0 to 100, and the BME280 can actually measure humidity from 0 to 100. Next step, we'll be talking about how we measure temperature. Okay, so finally, the last thing we want to talk about is how do we get temperature from this system? Now, what we know from Bosch, they haven't disclosed exactly the material and the exact mechanism, but they have told us that it is a diode mechanism in the BME280 that is used to get temperature. Now, the reason we use a diode mechanism is because diodes are really popularly known for their strong temperature dependence. And as I mentioned, the material and the exact diode mechanism are not disclosed, but we do know diodes in general do have a strong dependence on temperature. And if you don't know what a diode is essentially a structure in a circuit that allows you to impede current in one direction and allow it to flow in the other direction. So looking at this diagram on the right here, what we have is a circuit, and we have an LED in front of the diode. So based on the direction of this diode, with the arrow pointed to the right, electricity is going to be able to flow through that diode. Perfect. However, if we do flip the diode over, electricity will not be able to flow through the circuit, and the LED will not be triggered. That's how a diode works at a high level. There are many forms of diodes. There are large diodes, small diodes, MEMS level diodes. It's a really popular thing that is used to measure temperature in systems, and it's known to be very cheap and easy to implement, and that's probably why Bosch relied on a diode. It's very reliable, and you can essentially measure a dependence of temperature with very low current, so it makes it very power minimalistic to keep the system operating. So in the next slide here, I just have another illustration of sort of how this is working and why we do it. So when a diode is subject to a temperature change, as I mentioned, its forward voltage drops. So that's what diodes are known for. When the temperature of the system changes, the current that is essentially passing through the diode alters and the forward voltage drops. So they're known for this sort of thing. And so in this illustration here, what is happening is that we have a voltage that is measured in this diode system, and so electricity is trying to flow from the top to the bottom here to ground. And we know that with a change in temperature, what's going to happen is this voltage output is going to change, and that is proportional to a temperature reading we can deduce by knowing other properties of the system. And you may be asking, why is there a resistor here? Well, resistors are used in these kinds of mechanisms because resistors create a more stable and reliable current reading, and that creates more accurate temperature readings for us. So resistors help us get just a more stable system, in this case for the currents, and allow us to deduce what we want from the system more accurately. So that's all we know. Unfortunately, as I mentioned, many things, the exact operating mechanisms of the BME280 in terms of the material, exactly how it's designed, are not known and probably will never be known because they worked really hard to get that thing to market. It's a really powerful sensor. It can be used to measure even altitude because the pressure readings are so accurate, and you can buy that many places online. You can buy it soldered from Shilotech. So I hope you guys learned something in this video. If you are watching on YouTube, don't forget to like, comment, subscribe. That would mean a lot. If you have any questions or recommendations for future videos, let me know in the comment section down below. As always, guys, stay tuned. Thanks for watching, and take it easy.